Hello friends, you are watching This is Awesome Videos, and today we are going to learn about an important topic of complex numbers, and that topic is De Moivre's theorem. So now, how can we use this and when to apply this? This is a very simple formula of De Moivre's theorem, but very few people know about this formula and they can't solve the question if asked in the examination. So now, what is De Moivre's theorem? So it is, here we can see that De Moivre's theorem: for all values of n, the value or one of the values in the case where n is a fractional of cos theta plus iota sin theta whole raised to n. You can see that this cos theta plus iota sin theta is the general form of a complex number, cos theta plus iota sin theta. Then it's gonna equal to cos of n theta plus iota sin n theta. That means you can put this n in beside of this theta like this. This n comes here and this n comes here. The same thing applicable in the reverse manner. If you can find n here in both the cases, then it can go to the power of whole. That means this process is reversible process. You can apply n here and here, and if you can see n here, cos of n theta plus iota sin theta, then you can write like this: cos theta plus iota sin theta whole raised to n. Now when we can use this formula? This formula can be used for three types of number: when n is a positive number, when n is a negative number, both are integer, and where n is the fraction. In any of the cases, the answer is same: cos of n theta plus iota sin n theta. Then what it makes a difference? If n is positive, then nothing's gonna be a change. But if n is gonna be a negative, then what is going to happen? If n is negative, then you can see that what is going to happen if n is negative. We will see that if n is negative here you can see that at this point of dot, negative sign comes here, so sine of minus n theta. That means sine is an odd function, so minus comes out, that is, and cos is an even function, so this equation becomes cos of n theta, and here there comes an minus cos of n theta minus iota sin n theta. This is done when n is negative, and when n is a fraction, the same equation can be possible. Okay, now which type of question can be asked? Using this formula, the direct question also can be asked, or based on this particular formula can be used in other sums to solve that sum. Okay, now let me see first of all one example. Here you can see that let z is equal to 1 minus iota, find z raised to 10. So now if you can doesn't know this formula, then how you can do that? You have to multiply z 10 times and you will get the answer, but it takes lots of time. So if we know the formula, you just have to convert the z is equal to 1 plus minus iota into the polar form. Then how will you convert? First of all, mod z is equal to under root of, you can here see that 1 square plus minus 1 whole square. We all know that this formula is square plus b squared, where a is the coefficient of real part and b is equal to coefficient of imaginary part. So here mod z is equal to 1 square plus minus 1 square, that is root of 2, and argument of z, that means we all know that tan inverse of y by x. Here y by x, or we can see b by a, that means minus 1 by 1, that means minus 1. Tan inverse of minus 1, that means minus pi by 4. So polar form of this complex number comes out like this: z is equal to r cos theta plus iota sin theta, that means root 2 cos minus pi by 4 plus iota sin minus pi by 4. Now this is z. Now we have to find z raised to 10. So simply apply 10th power both the side. Now what we get here, z raised to 10 is equal to root 2 raised to 10 in the bracket cos of here cos of minus pi by 4 plus iota sin minus pi by 4 whole raised to 10. So by de Moivre's theorem, this 10 comes here and this 10 comes here. So you can see that in this slide 10 comes here and 10 comes here. So now as we simplify, cos of minus 10 pi by 4 plus iota sin minus 10 pi by 4, that is minus 5 pi by 2 iota sin minus pi by 2. That means now what we have to do, root 2 raised to 10, that means 32, 2 raised to 5, that means 32. Okay, now minus 5 pi by 2, that means minus pi by 2, and minus 5 pi by 2, that means minus pi by 2, because both the values of minus pi by 2 minus 5 pi by 2 both are same for sine and cos. So cos of minus pi by 2, that comes out 0, and sine of minus pi by 2, that comes out minus 1. So minus 1 into iota, that means minus iota, plus 0, that means minus iota into 32, that means minus 32 iota. So 1 minus iota raised to 10 is equal to minus 32 iota. So you can see that by knowing the simple formula, we can get the answer 1 minus iota raised to 10 is equal to minus 32 iota in the fraction of second. So you can apply this theorem at every stage in complex number. So please remember this formula. Thank you friends for watching this video. You are watching This Is Awesome Videos, and this is my third video on the mathematics topic for JEE. I'm going to post each and every topic wise video for mathematics and physics each and every day. If you like this video, don't forget to share it and hit that subscribe button. Thank you.